I'm Ed Nutman. I'm the safety consultant for NECA chapter, Lansing chapter. I've been involved in working with you folks for about 25 years. Today we're going to discuss Silica and understanding the requirements of a written program. I want to discuss the learning objectives. We're going to look at today at the history of silica in the construction industry and what its effects on workers have been over the years, in addition to looking at ways to mitigate exposures through best practices, as well as engineering and other control methods. We're also going to look at implementation and enforcement data. In this data are dates set by OSHA or MyOSHA, because MyOSHA has adopted the OSHA standard for silica, for proper compliance and understanding how Table 1 is meant to be used in the construction industry. Understanding what is required in a written program is key, and looking at personnel whom will be considered as competent persons according to OSHA and your company. Items not covered. Due to the nature of the presentation and the topics, we'll not be covering sampling procedures or tasks that are not normally performed by an electrical contractor employees. We're also not going to discuss the individual qualifications of a physician and licensed health professional. We are not familiar with your company's written respirator programs. We can only reference it here as your company's program relating to the final Silica rule. I also like to note too that you have to be concerned about your right to know program, and if that has been implemented and the training has been conducted. Rustable, again, crystalline silica. We know that silica is a natural occurring mineral found over the entire Earth's surface. Now, depending on the ingredients of a construction material, such as a brick or mortar or concrete, silica levels can range from a minimal exposure to high concentrations. Exposure to small, fine particles of silica, that which is rustable, is what our major concern is today. When we cut, grind, or drill into masonry products, there's always a potential for exposure. And we need to make sure that we protect our workers when they are exposed. Okay, there are three types of silica that accounts for most silica exposures. And there are quartz, chrysobolite, and tridymite. And since quartz is a natural substance and found everywhere, it is difficult to measure all natural occurring silica exposures if there's no visible dust. Rustable crystalline silica. The history. Sickness related to silica exposures, well, they date back early to the 1930s, when a tunnel and a dam were built at Hawks. Within 6 months of working on that project, many workers became severely ill and many died as a result of their exposure while working on that project. That is within the government began to take a real serious look at the conditions and workplace exposures of employees, which probably played a key role in early development of the OSHA and now the MyOSHA regulations for our industry. It's estimated that almost 2.5 million people are exposed in silica, again, workplace events. Okay, rustable crystalline silica health. Silicosis is the disease associated with silica exposures and usually specifies how quickly it develops and manifests itself in that individual. I want to note also, smoking and having a history of smoking can also accelerate this concern about silicosis. Acute silicosis results from short-term exposure to very large quantities of silica and overwhelms the body's defense mechanism. Accelerated silicosis can result from exposure to large amounts of silica over a 4 to 8 year time period. Chronic silicosis is a result of a long-term exposure to small amounts of silica for a very long period of time. Brick masons and roadway paving workers may make up the majority of the cases in this group. All right, rustable crystalline silica, other health effects. Other diseases that can be attributed to having complications arising from silica are COPD, that's chronic obstructive pulmonary diseases, tuberculosis, lung cancer, and renal diseases. While smoking used to be the #1 cause of preventable death in America, smoking, if you have silicosis, can also complicate treatment plans, as well as aid in the degeneration of the lung function. That's according to our medical professionals. Silica, current actions and permissible exposure levels, PELs. While with OSHA and MIOSHA's new silica rule, the action levels for silica exposures has been lowered to 25 micrograms per meter cubed, and the permissible exposure levels has been lowered to 50 milligrams per meter cubed. These are drastically lower than the previous values, which have general industry PELs at 100 milligrams per meter cubed and construction at 250 milligrams per meter cubed, with a higher action level for both as well. These values are also based on an average work exposure over an 8-hour time period. If work will be working longer hours per day, the values may need to be adjusted for proper compliance to exposure levels. Some final rules on silica important dates for you. Released. The new rules have been a long time in making. It was focused from our former Assistant Secretary, David Michaels, and he will be recognized as the person that made this final rule come to fruition. Yeah. It was originally released in May 23rd, 2016, the effective date of June 23rd of that year. It had delayed enforcement guidance, allowing employees to prepare for this new regulation. 1 year for construction and 2 years for general industry and maritime. Since these were originally announced, a future delay in enforcement of construction was changed until September 23rd of this year. That's Sunday, this Sunday. Okay, what does it mean, electrical contractor? What does it mean to me? What do I have to do to establish and become compliant with this new rule and regulation? So what is the construction employers, specifically an electrical contractor, should do at this time? What do we need to do? What do I have to do minimum, okay? Developing a company-written exposure control plan for silica is vital. This is an item that the compliance officers in the state of Michigan will be asking for, will be looking for, okay? Critical, right? This plan should include who is designated as a competent person, methods used to restrict housekeeping and work that expose silica to workers, review the medical requirements, and offer exams of workers qualified per standard. Train workers and supervisors on recognizing silica exposures, and the best work practices to use when working around silica. And finally, to ensure all proper record keeping is up to date, including medical records for employees. By the way, do you know how long an employer must maintain medical records? Correct answer is 30 years per OSHA and MIOSHA regulations, unless there is a temporary worker, and that worker for that company is less than 1 year, at which time you should provide all medical records to the employee at separation or termination. By the way, also their representative too, the union representative. Table 1 for construction. A lot of emphasis now for construction compliance is based on Table 1. A list of tasks and control provided in the updated OSHA regulation. Again, we should say OSHA/MIOSHA regulation. Many of the tasks that are performed in the construction are listed in this table, completed with engineering and work practices controls. It also lists when a respirator would be required, along with the recommended APF. That means APF, this means what is its ability to protect a person, okay? It's APF. Assigned protection factors for the respirators to be used. It also provides information about proper implementation, the engineering methods, and controls. I want to note that maybe a job safety analysis form might be helpful in this case. And we'll go into more detail on that in just a few minutes. All right, Table 1 again, versus an alternative method of compliance. Table 1, you identify what? Well, if you choose that part of your program, you're granted a reprieve in monitoring the PELs, that's permissible exposure levels, and conducting exposure assessments from your work site. And exposure assessment means air monitoring. Now with Table 1 listing of the task, engineering control methods, we can easily follow The Table 1 is also preferred method for use when compared to obtaining objective data and continuous error monitoring for Silica programs. Let's look at a few examples. Right off the bat here, we'll start off with, I think, the common things that we find in our industry and that tools we might use that might be used to cutting materials that would have silica in it. In Table 1, when you look at our example, on the very left-hand side, we have examples of equipment and task. The middle form, we have engineering and work practices control methods. And then the next section we have is required respirator protection and minimum assigned protection factor. That's the APF. And then the other column has what does full and proper implementation require. And that's again, italics and bright red. What do we need to do? Let's look at the first example. First equipment, handheld power saws for cutting fiber cement board with blade diameters of 8 inches or less. Go to the next column. What is our engineering work practices, our control methods for tasks performing outdoors only? Use a saw equipped with a commercial available dust collecting system. Okay, operate and maintain tools in accordance with the manufacturer's instruction or to minimize dust emissions. And then dust collectors must provide the airflow recommended by the tool manufacturer or greater and have, again, filters with 90% or greater efficiency. Would you go to the next column, required respirator protection and maximum assigned protection factors? Note, 4 hours or less, none. So I'm working and exposed to that using that table saw or that hand saw. 4 hours or less, I don't need a respirator. 4 hours or more, I still don't need a respirator. Go to the other column. Again, what does full protective implementation require? Well, dust collecting system, the shroud or the cowling, okay, is intact and installed in accordance with the manufacturer's instructions. The hose connecting the tool to the vacuum, okay, intake and without kinks or tight bends. The reason why it would reduce the flow, again, the ability to the vacuum to suck up any of the dust particles. And that by crimping them, certainly obviously would do that. The filters on the vacuum are cleared or changed in accordance with the manufacturer's instructions to prevent what? Clogging and inefficiency. And the dust collection bags are emptied to, again, avoid overfilling. That's just one of the examples. And if you'll notice that on the other side of our table, you're going to see, again, jackhammers and handheld power chipping tools. I don't think, again, we use that a lot. I find that it's been my experience is that a thing like on our next table, let's talk about equipment here. We find that you go and outsource this. You just sub this out. Handheld or standard mounted drills, including impact or rotary hammer drills. Yeah, maybe some of that might be done, but a lot of times some of that stuff is done outside by an outside contractor. Okay. Elements of the written exposure control plan must include a description of the tasks that may involve exposure to silica dust. When can I do this? What tool can I use or what form can I use to help me do that? Describing the task that's involved. I would recommend that you do a job safety analysis form, which you go and describe the task. Then in the column, you put down the potential hazards or known hazards. And then in the other column is, how do I protect somebody? Do I use the engineering controls? Do I use the administrative controls? Or do I use the PPE? Again, you can use any combination of the last two because you might not be able to engineer out that hazard or the potential hazard. Now, a description of engineering controls, work practices, and respiratory protection used to protect the employees. We saw that in our tables. And a list of housekeeping measures to limit the employee's exposure to silica dust. That's it. After you've done all that, creating all that rubble in that you're drilling through brick or block walls or floors or whatever else is, you got to clean it up. And there's an exposure to that also. So again, how do we protect our people there? Some people, when they're doing sweeping up, you just don't sweep it up with, the typical broom or whatever else is. Some have actually used this is old school, and that was, they call it cleaning compound, which was like sawdust with oil in it. And then they would spread that out, and that way they would sweep up some of that dust accumulation. Construction also includes procedures to restrict access to work areas. Name of designated or competent person. I want to go back to the procedure to restricted access to work areas, and that's something that's very critical, very critical. Examples of tasks. Let's look at tasks. Drilling holes for anchoring in tile, concrete or concrete blocks, cutting concrete such as pads, sidewalks, or duct banks, chipping or jackhammering concrete, cutting asphalt or other roadway materials, using power-actuated tools, and excavating earth and rock-containing silicates. Other factors that influence the movement of dust or how the dust is handled within your work area and the task you're being performed. Environmental-related conditions would be weather, wind, humidity, and location, indoors and outdoors. You're probably not going to be able to go and use a water system indoors, and a proximity to an electrical circuit, again, is critical. So again, the tools with the vacuum system is probably one you're going to have to find yourself using. All right, control measures. Engineering controls, that's what we want to do. Engineering controls, in addition to any respiratory protection. Ventilation, vacuuming, wet cutting procedures, and best practice. And then it says other means to reduce or eliminate exposure. Those are calls that are going to be made by that competent person in the field. We don't know what that would be, and only they will be able to go and make those decisions and capable of making those decisions at that time. Again, housekeeping measures. Cleaning methods is to permit, reduce, and prohibit generation of airborne silica. Compounds for sweeping, like I said, from the old school. Locate exhaust for compressed air cleaners. Clothing and hygiene, respiratory protection needed. I think one of the things that I'm concerned about here is when I think about clothing and hygiene, I'm thinking about not having an employee having silica dust all over their person and then in their work clothes, then coming home to their family and thus exposing them to that silica exposure. And that happened, and it's happened even with the asbestos over the years. Around restricting access to areas containing silica, construction employers using Table 1 must what? Restrict access to bystanders in any area where a respirator is required or when the PEL is exceeded. PEL silica is exceeded. Critical. In other words, we're thinking about this is I'm creating this hazard by doing this particular task. Am I exposing some other trade, some other contractor's employees while I'm doing this? We have to be concerned about that. We might have to make people aware of what we're going to do, and there's a possibility that there could be an exposure. So again, if you're working with a GC or other trades, let them know the story, and thus then they can move their personnel away from the area and thus reduce their exposure or eliminate the exposure. Well, the methods we're talking about now are demarcation of areas, notification of job briefing, and effective employees. Again, if you have the weekly safety meetings, and again, when we come into our progress meetings, one of the first things that they cover is safety, and that's something we're thinking ahead. What are we going to do the next week? The task we're going to perform, and make the other trades aware of it. Administrative control areas by scheduling work when others are away. Makes sense. Makes sense. And methods chosen must be documented in a written program. Okay. Competent person, defined as an individual who is capable of identifying existing and foreseeable crystalline silica hazards in the workplace, and who has the authorization to take prompt and corrective measures to eliminate or minimize them. So that's a big responsibility. In other words, that person could stop the job, stop the work, until either you're going to go and what? Control or eliminate that hazard of the silica dust. Remember, the person must be willing to accept that role to be a competent person. And his company must designate and authorize them to do just what we said. Again, make those changes in the field. Critical thing. Competent person must also be trained in the rules and regulations pertaining to silica. Now, being knowledgeable of the MIOSHA standard or OSHA standard on silica is one thing, but we're also depending on what? Depending on their experience and just good common horse sense that they know the tasks that are being performed. So their duties are going to include recognize areas where exposures could exist, Yeah. Evaluate the exposure potential. That takes some background. That takes some experience. Okay. And provide recommendations to control those exposures. They're key person here, competent person, must be well qualified, and remind me a lot of additional training for your competent person. Now, medical surveillance. We're hoping that we don't have to go into this medical surveillance problem because it's expensive. The regulation require a plan for medical surveillance of employees who wear a respirator 30 or more days a year. Now, I want to state this is, even if an employee is doing a task in this procedure for a short period of time, even 15 minutes, it would be considered the same as if the person worked all day and was exposed to the silica dust. So 30 days or more a year. Record keeping documentation. Again, when you're going to see 29 CFR 1910, that's a general industry standard that has been adopted by the construction industry in this case about record keeping. In other words, record keeping requirements are there for the manufacturing people as well as the construction people. And what are those record keeping documents required? Exposure and air monitoring dates or data and medical records. Okay. Now, what about these medical records? We say we're going to keep them for 30 years. Okay. What happens? We have a person who's employed here, we does task work and so forth, that type of thing. How long and what do we keep? How do we keep the records? And the person moves on. What do we do with those records? What happens to those records? Well, we have an obligation to again make available to the employee those records that they can go to the next employer or wherever their work experience might take them. All right. Hazard communication, 29 CFR 1910 1200. That's the right to know standard. Okay, it applies to all of us. Initial hazard communication training. When I say that initial hazard communication training is, you have to make your people aware of what hazards would be provided in the task that they're being performed when it comes to silica. But also could be asbestos, it could be other things that come into play. So initial hazard communication training, you must make them aware. There must be some kind of training. In any of the standards that we have, all the standards that come into play, whether it's training is required, they're going to require certification. What does certification mean to you? Well, certification means that they have a sign-in sheet, that the instructor signs it, and that I'm going to recommend to you that you also have some kind of test, a real simple test, to determine if the person understood what you were trying to train them in or make them aware, or the word is cognitive, of the hazards that they were going to develop when it came to silica. Remember the hierarchy of controls. What is the hierarchy of controls? Engineer out the hazard or potential hazard. Again, administrative control the hazard, or third, personal protective equipment. Again, you might not be able to engineer it out, but what you want to be able to do then is going to have to use to control the exposure to your employees. You're going to have to go and do the training. You're going to have to make, signage to make people aware that this is a hazard, situation or condition, and you're also going to have, certainly provide the PPE. So again, recognize the knowledge of silica hazards, proper warning labels and notification, exposure control methods, and certainly personal protective equipment. Alternative methods of compliance, performance options. It requires exposure assessments to be performed using air monitoring data. Objective data or combination thereof will actually characterize the breathing in of chrysotile silica in the work exposure. Again, we talked about air monitoring. That is a situation in which you're going to have to be involved with using a pump, a monitoring mechanism that picks up the data, the silica dust, how much is exposed in the breathing zone of the employee. They're also going to have some lab work done in monitoring and determining what the actual exposure is to that dust collected. Objective data, air monitoring data from industry-wide surveys or calculations. Again, industry-wide, well, again, how about electrical contractors across the country doing similar work? A lot of us do the same things. We want to have objective data. That was going to determine if we can use or not have to use certain methods like a respirator or whatever, because it's proven that, again, when I do this function, that there's a limited number. We're below the exposure level, the permissible exposure levels, and then we can do this without respirators. And that's what we want to be careful about. When do we have to use respirators? Demonstrate relative exposure to products or materials related to a specific gas process or activity. A particular product material. How do I know what is this particular, let's say, board or whatever we have? We were talking about drywall or whatever. Do we know that the mud and the tape and the material itself, does it have silica in it? We were going to have to go to the supplier. We're going to have to get the material safety data sheets. Oh, I better correct myself. The safety data sheets, because that's going to tell us what the content of that particular board material is for mud or whatever else we're using. It must be representative of the workplace conditions or exposure potential faced by employees and the workers. In other words, if this is a standard exposure, this is a task that electrical contractors employee would do anywhere in the country or on any job, again, what's the data told us? Historically, what has the data told us what the exposures were to silica dust or lack of it, that type of thing. And maybe the methods that we're using to go and control. I said the word control, the exposure to that dust. Alternative methods of compliance. Scheduling monitoring options. Boy, that's a costly situation. It requires a schedule for initial and then periodic personal monitoring. Again, your employee's going to be wearing a pump, and it's going to have a monitoring device at his collar where his breathing zone is, and it's going to measure the amount of particles of silica dust that person could possibly have breathed in without any kind of protection. Initially below action levels, no additional monitoring is required. Below action level. And we've determined what that action level is earlier in our presentation. At or above the action level, we have to, again, this monitoring has to be done within 6 months. Above personal exposure levels, repeated within 3 months. When 2 consecutive non-initial monitoring results takes at 7 or more days apart are below the action level, monitoring can be discontinued. That's a costly thing, and they've given you an out by that. When 2 consecutive non-initial monitoring results take at 7 or more days apart, and they are below the action level, monitoring can be discontinued. Reassess if conditions or circumstances change. Again, that competent person in the field is the person who's going to be key here. Alternative methods of compliance. We want you to refer to Appendix A of the standard. It says the methods of sampling analysis and the final rules on silica for more information. Now, a lot of these appendices, and there are many, many items and rules that are coded in that appendices, but what it does, it tells the medical community as well as the labs that would be doing the analysis of the silica dust, the procedures they have to use, the formulas that they have to use. Okay, alternative methods, again, in compliance may use engineering or work practice controls to limit exposure to the